1, so that's about 1.15 if you round it. And that's equal to our inner brackets here of 1 plus x% over 100. And then if you just subtract off your 1 on both sides and multiply the 100%, you'll be left with that 15% that I rounded up to.
Okay. Yeah. Something. Yeah.
So I know we kind of walked through that a little bit fast, but does everything make sense? It's clear?
Yeah, definitely.
Okay.
Yeah.
Okay, perfect.
This one is very clear.
Okay.
Yeah.
Usually I have a pen to write with, but it broke the last session, so I'm using my mouse, so it's a little hard to read at times, but I'll try to do my best.
Yeah. Okay, that's okay. You've taken a screenshot, so.
All right. And go back to the next problem here and snip it over.
Next one.
All right. And then there's a few other images here. Okay, so this one was kind of one that I thought was ambiguous because it didn't really tell you what you need to solve for. I kind of stopped when I just got V. I'm taking that as like the angle here in degrees. So that's what I solved for. I really don't know if that's what they wanted you to solve for, but they didn't give you any other lengths. Everything is pretty much just a variable and left like that. So that's how I approached it. Hopefully your teacher is lenient or might give you more information if they want you to solve something else. But they're pretty much just saying that this slope here at V is represented as a ratio between the height and the length. So you can just rewrite that as the 10% is equal to your B over A. It's supposed to be a decimal. And then what you could use is tangent, because that's the opposite over adjacent. Does that sound familiar? To get an angle, you have tangent of your opposite over your adjacent would give you some, we'll say that that's V in degrees. The only tricky part here is that they gave you this 10%. So that's where I was thinking, well, I guess you could solve V in terms of degrees. So, I'm sorry, this should be an inverse tangent. So be tangent of the angle is equal to your opposite over your adjacent. So if you just inverse tangent your B over A, you can get an answer in degrees. So that's just inverse tangent of 0.1. Pop it in your calculator, and you can let me know what you got. I know I had my calculator in radians at first, so I had to change the mode on it. It was giving me some nonsense.
Is this just a normal 10 or what? What's this? 10?
So yeah, so it's 10% is what they gave us as equal to B over A.
Yeah.
So it should be 10% over 100% equals 0.1 or 0.10 is what I try to write there.
Yeah.
Is equal to your B over A.
Okay. Cleared. So what I see here, it's like you have to find what's the slope? I think something related to the slope.
The slope size. Yeah, that's where I was I didn't know if slope size, they meant this angle here, or they're talking about the length of it. Because in order to get the length, like your hypotenuse length, you need A or B to be given as something like B equals 10 feet or something.
Yeah.
But with what they gave us here, I mean, we could find the angle. We could maybe express the hypotenuse in terms of A or B by just using like sine or cosine. But that wouldn't give us like a value. So that's why I was kind of unsure if, at least once you get this angle, you can use sine or cosine, and hopefully, but your teacher might give you more information on where to go. But if you're familiar, or are you familiar at all with like using sine, cosine, tangent, and all that?
Yeah, exactly. Because
Okay.
if you look at it, you have A and B.
Correct.
And this adjacent, I don't know, how do they call this? This longer side doesn't have a value.
Right. So usually like the hypotenuse.
Angle B. So I don't know if you have to look for this, because if it is like this, maybe I need to check it if it's a cosine or a tangent.
Okay. Yeah. Because you could use, let's see, you could use either sine or cosine. Once you have the angle that we solved for, you could say that the sine of that angle V in degrees is equal to, that's the opposite over hypotenuse. Which in this case, the opposite would be B, and we still don't know what H is, but at least you could write it in terms of what was given here. So just rearranging that, you would have your, if we're solving for the length, it would be B over sine V.
Yeah.
And when I did this calculation, my V in degrees was, what was it? 5.71. 5.71 degrees.
Okay.
So that's probably where I'm going to have to leave you off on that one. I don't think there's enough information to really go much further than here or here.
Yeah, exactly.
Yeah. But was all that clear, or is there any questions left over?
Yeah, it's clear. I for now I have a clue.
Okay.
Yeah.
At least know the direction where to go.
Yes, exactly.
Okay, perfect. All right. This last one, definitely it looked like there was some lost in translation.
Yeah.
It was interesting. So yeah, where to start? You have the PDF in front of you, right? Because this would be a lot to copy over.
Yeah, but
copy over the image at least.
Check if I can find the document somewhere.
Yep.
Should be here. Yeah. 1 minute.
All right.
No.
Let's see.
No. Because I've never come across this formula. It's my first time of seeing this.
It's all good. My first time seeing this formula too. Whatever this formula is. So let's see, going through it, they pretty much tell you at the beginning, because they're saying that there's a circular pipe half filled with water, which is what the picture over here is illustrating. They're telling you off the bat some initial conditions. They're just saying that when the Manning's M, which is the M in the formula here, is set to 70, that the line has a slope of 25. It's kind of weird there because in the problem statement it says 25 per milli. I'm not really sure what that means. If it was trying to say per millimeter, I ended up Googling this this formula, and the line slope, which is this SB, has units of length per length. So really it should be unitless. So I just took it as initial conditions, M equals 70 and SB equals 25. This one is like a length per length value. So even if it was like millimeters per millimeters, it would just cancel out. This one, in the problem statement, it shows it with no units, but for the formula to work out, there would be some funky units with this, like some meters to like the 2/3 or something like that to cancel out. So I'm just gonna say that there's assumed units that make it work, as long as the other values that they gave us, like the cross-sectional area, it says it needs to be in meters squared. The Q is going to be in meters cubed per second. So as long as we keep that in mind, I think we can just use the assumed units will cancel out.
Okay.
So we at least know some of those values. A, it's asking that is the cross-sectional area of water. So let's say this is telling us it's in meters squared. Cross-sectional area of water. What's our next one? You could also say what Q is while we're here. Q, they said, is in meters cubed per second. And that's going to be our volumetric flow rate. They express it as volume of flow or flow volume. Volumetric flow rate is what I was used to. R, it looks like it's a subset of something else. It's a different equation. It's R is equal to A divided by P. A is the same thing as above. Same as above. P is going to be the wetted perimeter. Yeah, it's just the wet perimeter. Only water touching pipe. And then SB, they said, is our slope, which was given already. Manning's number. All right. I believe that's all the information that they provided us with. Still here, still good, following along? I don't know if I have chat open, so maybe you wrote something there. Let me know when you're back, Victor, and then we can jump into solving this.
Yeah, I'm here.
Okay.
Yeah.
I just saw your camera go off, so I wasn't sure. All right, so they gave us these initial conditions, the M and the SB. We are trying to solve for Q, so that's what we don't know. This they gave us, we're good there. Highlight that one. They gave us the SB, we're good there. So really what we need to do is figure out what A and what R are. Since R is a function of A, we might as well just start off with solving for A. So A is the cross-sectional area of water. So we're looking for this area here. We're already looking at the cross section of the pipe because we're looking down the pipe from this image here. So we just want to figure out how much area is this taking. Do you know any formulas for an area of a circle? Anything jumping out?
Pi radius square.
Sorry, what's that?
Pi radius square.
Perfect. All right. So that would be if it was the whole circle. So if we just take that and divide it by 2, we'll be left with our cross-sectional area of just the water. And we can confirm that because from here up to the center is 250. And if we were to look from here all the way to the top, that's 500. So it is indeed just half. So we can use that. Say that A is equal to pi r squared. And we're going to divide it by 2. So here we have to keep in mind the units. They've given us everything in millimeters. And everything that we're working with our equation is in terms of meters, whether it's meters cubed, meters squared. So we should convert this before we actually manipulate it here. So to go from 250 millimeters to meters, that's just a conversion of 1,000. There's 1,000 millimeters in 1 meter. So that leaves us with 0.25 meters. So we can go ahead and plug that in up here. We've got pi times our 0.25 meters. That quantity is squared and it's divided by 2. So we figured out what A is. We know that once we square this value, we're going to be in a unit of meter squared, and that's what our problem told us we needed it to be in. So we're good for area. I'm going to go ahead and type that in up here. So if you solve that on your calculator, let's go ahead and type that in, get a real answer here. Pi times 0.25 squared. Divided it by 2, and I get a value of 0.098. So I'm just going to type that in. It's meters squared. So looking at R now, our last unknown, we've already solved what A is. So we're good there. Now we just need P, which is the wet perimeter. For that, we're only looking at this portion. Ooh, this is gonna be tough. You can imagine that that just touches where the pipe and where the water meets. It's just that wetted perimeter. So similar to how you solve for the cross-sectional area of water by using the area of a circle, can do something similar here and just use the circumference of the circle, except since it's half, we're just going to half that formula. Let's do a different color. So our P normally that would be 2 pi r for circumference of a circle, but we need exactly half. So we'll divide it off by 2, and we're just left with pi times r. Similarly, like we did up here, instead of using the 250 for our radius, we're going to have that converted into units of meters. So we're going to use the same value up here. It's going to be pi times 0.25 meters. And that's going to be what our P is. So now we can solve for R, and I've left these alone because when we solve for them, we can have some stuff cancel out. So using both these, R is equal to A, which is this, pi 0.25 squared over 2. And then our P is pi times 0.25. So you'll see some stuff cancels out. Can cancel out the pi here. Can cancel out one of these 0.25s. So just get rid of the square, get rid of this. And now all I'm left with is R is equal to 0.25. This had a value of meters. So it's 0.25 meters over 2, which is also equal to 0.125 meters. So we can go ahead and write that up here. So we have everything now to go ahead and solve the problem. We don't know where the Q is, but we're trying to solve for that because we need to find the volumetric flow rate. M, they gave us at the start, they said that it was 70, and that when it was 70, our slope SB would be 25. So we know both M and SB. A, we just solved as 0.098 meters squared. And R, we also just solved as 0.125 meters. So since this doesn't give you the units for M to manipulate the units on R here, I'd say we have everything in meters. So we're good to just plug it in and assume that that would give us our Q in meters cubed per second. So plugging this in, got Q equal to 70 times 0.098 times 0.125 raised to the 2/3, followed by 25 raised to the 1/2. So when I solved this earlier with these values, I got Q is equal to 8.589. So I'll just round that up. Q equals 8.6. And this was under the assumption that this gets us our Q in terms of meters cubed per second. So that was one of the things the question asked us to solve for. I believe it was find the volumetric flow rate. Yep, the flow must be expressed in both meters cubed per second and liters per second. So we've expressed it so far in meters cubed per second. The last thing to do would be a unit conversion. So we have, just right up here, that 1,000 liters is equivalent to 1 meter cubed. So all you need to do to express it in liters per second is just multiply this value, your 8.6, times the 1,000 liters per meter cubed, and both your meter cubes will cancel out. You'll be left with liters per second. So that would just be, as a rounded number, 8,600. Liters per second. Do you have any questions for this one?
No, not really. I think everything all looks great.
Okay.
It's okay.
So do you feel confident then for completing these questions on your own moving forward?
Definitely.
Perfect, perfect. All right. Well, thank you for stopping by. If you have any future questions, always reach out to Miss Lillian and she'll try to connect you to someone if she can't help you herself.
Yeah, I think I have a Zoom link now following.
Perfect, perfect. Yeah, always feel free to stop by. Normally, this is a 5th and 6th grade question, but she let me know that you need some help for this, so always willing to help out. But we're going to move into doing some 6th grade math here shortly. So if you have last minute questions, feel free to ask them. Otherwise, I'm going to jump into doing that.
No, not yet. No, I think everything is okay.
Okay, perfect.
Zoom. Yeah.
All right. So then we're going to jump into 6th grade math here, Jaden. I heard that you're using multiplication and division of integers right now. Last week, Sam went over doing some multiplication with decimals, so this might be a little bit of a step backwards, but we can just review this again. So when you have a plus times a plus, we get a plus. When you have a minus times a plus, you get a minus. And when you have a minus times a minus, you get a plus. And the trend is very similar for doing division. Follows the exact same thing. You're doing a plus divided by a plus, you get a plus. A negative divided by a plus. Or if we were to switch that around and say it was a positive divided by a negative, you'd end up with a negative. And if you're dealing with two negatives and dividing it, you end up with a plus. So moving on to our first question here, we have -7 times 6. Correct, -42 is the answer that we got. And once again, we're having a minus times a positive. So that's going to leave us with a minus, and then 6 times 7 at 42. How about this? We have -3 times -1. We have a negative times negative. So that should give us a positive. And then we have 3 times 1. So that's going to be a 3. Yep, +3. This one, 2 times -3. We have a positive times a negative. So that gets us a negative. And 2 times 3 gets us a 6. Yeah, go ahead, Jaden. Jaden's got some homework help, so we're going to go ahead and go over that. So he's going to screen share here. So let me go ahead and stop sharing here. Go ahead, Jaden.
Can I share my screen now?
Yeah, did you hear me? You can go ahead. Are you sharing anything right now? Because I'm not seeing it.
I'm about to share.
Okay. Is this your homework from today or for tomorrow? Trying to get in before it's locked out. Okay, I've got those 1, 2, 6, and 7. Let me get these other ones here. Okay. Got all those. So it's just those 1 through 10?
Yeah.
Okay. Just give me one moment here. I'm adding them to my screen share. All right, so let's go over this. So up here, they're just giving you instructions on how to deal with dividing fractions by fractions. So you leave the first one alone, and then if you flip the second one, you can change from a division sign to a multiplication sign. Do you feel comfortable with doing that? You flip the 3/4?
Yes.
Cool. All right, so let's jump right into it then. We'll leave the first fraction alone. We got 7/2. we can multiply by the reciprocal of this by flipping it around. So that's by 4/5. What would that get us? Got the top portion is 7 times 4.
That would get us 21/10.
So 7 times 4? I think you're a little off. 7 times
28/10.
3, yep, there we go. 7 times 3 is 21, so we have 28. Ooh. 28 over 10. Should we leave it like this, or should we reduce it down a little bit?
Reduce it down.
Okay, so how would we reduce that down?
It would
Do you share
be
something in common?
2 and 4/5.
Oh, so you really reduced it down. Okay, so if you pulled out a 2 from each one, right, you would have 2 times 14 and 2 times 5. You got rid of the 2, you had 14 over 5, and then you said that 5 could go into 14 2 times and have a remainder of 4/5, right? 2 and 4/5. I agree. I think that's your final answer, 2 and 4/5. All right, how about number 2?
Okay.
We've got 4/6. We're gonna leave that one alone, changing this to the multiplication sign. We're gonna flip the second one. We've got 4 times 3 for the numerator is gonna be
12.
12, and 6 times 2 for the denominator,
12.
12. So we got 12 over 12. What's that gonna reduce down to?
1.
Perfect. All right, let's just jump to this one since it's here. Got 3/5. Changing that to a multiplication sign. And we're gonna flip this second one here. Looking at the top, we've got 3 times 2. It's gonna give us 6. The bottom, we've got 5 times 1. It's gonna give us 5. And we're gonna reduce this down. 5 can go into 6 one time, so we got 1, and we have a remainder of 1 over 5. We can always check this. 5 times 1 is 5, plus 1 is 6. Yep, 6/5. All right, last one on this page, we've got 2/3. Gonna change that to a multiplication sign and flip this one. So for the numerator, we have 2 times 5. It's 10. The denominator is 3 times 2, which is 6. We can reduce that down by pulling out a 2. So that's the same as saying 2 times 5 and 2 times 3. Our 2's cancel out there. And you'll notice that's very similar to back over here, right? So we could have just canceled them out from the start. We could have said, we have a 2 up here, we have a 2 down here. Why even multiply them? Let's just cancel them out. And we're left with that 5 over 3, right?
Yeah.
So we could reduce that down from 5/3 to 1 and 2/3. All good on this one? Ready to go on to the next problem? The next group of problems?
Yeah.
All right. So same thing, 6/7. I'm gonna change this to a multiplication sign and flip this one. So we have 6 times 2.
12.
And 7 times 1.
7.
Perfect. And then what does this reduce down to?
1 5/7.
Yep, I agree with you. 1 5/7. All right, let's jump down to this one. 2/3. Changing this to a multiplication sign, flipping it. 4/3. Got 2 times 4. Gives us 8, and we've got 3 times 3. Gives us 9. I don't think we can reduce it any further, so we'll leave it like that. Moving on to number 5. 5/11. Change this to a multiplication. 3 divided by 2. What does this get us? 5 times 3. What's our numerator and our denominator on this one?
What did you say?
What's our numerator, our top portion, the 5 times 3? Got 5 times 3. What goes on the top here?
15.
And then on the bottom?
22.
Can we reduce this at all?
Yes.
Yeah? How are we going to reduce this?
1 7/22.
1 7/22. If this was maybe 22/15, I think that would work. But we've got a smaller number on top. So let's see.
No, it can't be reduced.
There we go. Yeah, if this was 22/15, then yeah, I think you'd be right. We would have that equal to 1 with 7/15. But we have it, this one. So we're going to leave it as this, 15/22. Final answer. All right, how about this one? 9/13 multiplied. So changing this around to now 3 divided by 2. So what do we have? What's 9 times 3?
27.
27. 13 times 2?
26.
All right. Can we reduce this one?
One and 1/26.
Yep. 1 and 1/26. All right. 1/3. Changing this to a multiplication sign and flipping this one. What do we get there?
4/9.
Can we reduce this one?
No.
I agree with you. So we'll leave it at that, 4/9. Got last one here, 1/3. Changing this to a multiplication sign. flipping this one to 3/5. Do you see anything we can do before we multiply it out?
3/15.
So we could do that, or remember like earlier, there's one on the top here and one on the bottom of the same number. We could just cancel those out, right?
Mm-hmm.
So we could say that this is 3/15, or if we cancel this out, we'll get what?
1/5.
Right. And is 1/5 the same as 3/15?
Yes.
They're equivalent? Yep. Same thing. So we could pull out a 3 from each one. We could say this is 3 times 1. We could say this is 3 times 5. And then we cancel our 3's because they're the same, and we're left with 1/5. All right. So what kind of problems are you going to go into this next week? Are you still doing multiplication and division of these fractions?
Yeah, I'm still doing that.
Okay. Do you feel confident on working with decimals from when Sam went over them?
Yes.
Okay. So going into next week, what kind of problems do you want to do? Just your homework again? Were you almost locked out of it before you shared it?
No.
No? Okay. Is that today's homework then, not Tuesday's?
Yeah, this is stupid.
Oh, okay, gotcha. All right, well, next time, if you just want to take some screenshots of your upcoming homework, like the Tuesdays ones, and save those, you can always do that, and we can go over those too, if you feel really good on your Monday homework.
Okay.
But other than that, it looks like you're good. Was this all of your homework for today? Only 10 problems? Perfect.
Yeah.
Okay.
Thank you.
Yeah, you're welcome. So coming up next, a few minutes here, we're going to have the 3rd and 4th grade session. So feel free to stick around for that. Otherwise, that's going to conclude it for the 5th and 6th grade sixth grade presentation. If you have any questions, feel free to put them in chat and I'll be happy to answer them. If you have any topics that you want us to go over the next week for the 5th and 6th grade program, just shoot an email out to Lillian or type it in chat and someone will let us know. All right, thank you guys. Have a great day.
All right, I see we have Jaden on. I'll wait a minute or two and see if anybody else joins for the 3rd and 4th grade session. All right, I see we have some people watching on YouTube as well. So I'll go ahead and get started. Today we're going to be talking about fractions. If anybody joins and has any questions about homework, we can go over that as well. But we'll start off talking about finding the common denominator for fractions. All right, I want to make sure my screen sharing is working before I get started. Can you guys see the screen? Okay.
Yeah.
Good to go. All right, so when you have two different fractions, it can be important to find a common denominator for those fractions. And just as a reminder, the denominator is the lower number on a fraction, and the numerator is the upper number. So this first problem A, 3/4 and 1/6, the 3 and the 1 are the numerators, and the 4 and 6 are denominators. And if we want to add or subtract fractions later on, we're going to have to get the denominator to be the same. So that's what these three problems are going to go over, how to get the denominator to be the same with these two fractions. So let's start with 3/4 and 1/6. These are shown by these pie charts here, 3/4 and 1/6. And the first thing to do when you get two numbers, two fractions like this, and you want to find the common denominator, is to start writing the multiples of the denominator. So the multiples of 4 and the multiples of 6, because we have to find a number that both of those numbers can be multiplied into. So we want to multiply 4 by something, and we want to multiply 6 by something, and then end up with the same number. And I'm going to use a table to do that, to start writing out the multiples of 4 and 6. So first, 4 times 1 is 4, and 6 times 1 is 6. Let's see, is that big enough on the screen? I'll bump the size up a little bit. Okay, here we go. So 4 and 6, let's get rid of that for a minute. 4 times 1 is 4, and 6 times 1 is 6. Now those aren't the same, so we got to keep going. So 4 times 2, we'll write down next, is 8. And 6 times 2 is 12. And still none of these numbers match. None of the numbers on the left match the numbers on the right. So then we keep going. 4 times 3 is 12, and 6 times 3 is 18. And now we have matching numbers on the left and the right. The 12 matches between the left and the right. So that is our common denominator for 4 and 6. 4 times 3 is 12, and 6 times 2 is 12. And if we want to show that on these pie charts, it should end up looking sort of similar to these pies on the left, but with more slices. So if we were to take these 3/4 and divide the whole thing up into, divide it by 3 again, basically, we will have, let me write this out, 3/4.
Hi.
Hey, how's it going?
Good.
We're going over fractions right now. We're talking about finding the common denominator.
Okay. Is this 3rd and 4th grade?
Yes. Are you in 3rd grade or 4th grade?
I'm in 3rd.
3rd? Okay. Have you learned about fractions yet?
Never.
No? Okay. Maybe we'll back up a little bit for a minute then and talk about, or do you have any specific homework problems that you need help with?
What?
Do you have any specific homework problems that you need help with? Esther, can you hear me? Yeah. Do you want to continue with fractions, or do you have any questions about any problems with your homework? I can't hear you. You have to unmute yourself. Let me see if I can.
I want to go on with. I don't want to go on with freshman.
Okay. What do you have questions about? Do you have any math problems that you're having issues with?
It's 12 times 6.
Esther, you need to pay attention. Sister in class, I can see you. Thank you. So the question is, do you have any homework that you need help with? Okay, so if you have homework, whenever you're ready, James is gonna share his screen. He's gonna stop sharing. Jane, you don't have to share. You don't have to stop right now. Whenever she. Do you have?
I'm not doing online anymore.
Okay, so but do you have any homework that you have available?
Yes.
Okay, so how can you share your screen, or is there a way we can get that information?
I will show you guys.
So what topic are you covering? Oh, multiplication. Okay.
I already did.
Oh, you did that already? Okay. I'm sure James has some multiplication problems. So basic.
Yeah, well, we can go through some multiplication then.
I need help with. Oh,
these are multiplying fractions. Let's see.
times 2. Times 2 is. I can't. What's 9 times 2 again?
Okay. So did you say you're having trouble with multiplying by 12?
Yes.
Okay. Well, let's do some problems down here then on multiplying by 12. So what's a good example a multiplication problem times 12 that you want to do?
12 times 9.
12 times 9? Okay. Let's
Then
write
like 12 times 6.
12 times 6.
And then the 7th.
All right. Say 12 times 6. So when you're multiplying 12 times 6, what you can do is write it out as this. Let me see. So 12 times 6. And now you can do it one digit at a time. So you've got 1, 2, 12 times 6. First, you can multiply the 6 times 2. So what's 6 times 2?
6 times 2 is what's 6 times 2? That's gonna be
What did you say?
12.
12? Yeah, that's right. 6 times 2 is 12. So we write 12 down here. And that's 6 times the ones place. And then we go to the tens place. And we have a 1. So first we write in this row what the 6 times the ones place is, which is 12. Then we put a 0 down here for the tens place. And we'll multiply 6 times 1 and put the answer right here under the 1. So what's 6 times 1?
6 times 1 equals 6 times 1. It's 6.
That's right. And that means, so once we've got the 6 times the ones place, 12, and then the 6 times the tens place, which is the 6, 0, so 60, we add those two together. And that gets us 2 and 7, so 72.
Wait, what? So then, do I do 12 plus 6? Oh, yeah, I get it.
You see what's going on? So you're multiplying this 6 times the ones place, and that gets you the 12. And then you're doing 6 times the tens place, and that gets you 60. So you've got a 60 plus a 12, and that's 72. Let's try it with a lower number. Let's do 12 times 5.
Yeah.
Okay. So 12. Whoops. 12 times 5. Okay. Are you able to draw on here?
Yeah.
Okay. Why don't you try this one?
2 times 5 is, well, is it 12 times 5 or 2 times 5?
12 times 5. That's the one.
Okay.
Yeah. Oh, okay.
That's easy.
60. So you just knew that one off the top of your head?
Yeah.
Okay. Well, that's another way to do the 12s. It's just to memorize them. And so 12 times 5, yeah, you're right. That's an easier one. Another way we could have done this is if we, let's see, if we had done 5 times 2 is 10, and then put a 0 down here and do 5 times 1 is 50, and we add those two together, and that gets us 60.
I have a question.
Yeah, go ahead.
I don't really get it.
Okay, you don't, are you having trouble with this addition in the multiplication, or where to put the 0, or what do you think is?
I'm having trouble with the addition.
What?
I'm having trouble with the addition.
Okay,
Yeah, the addition.
so what I did here is I kind of split this apart. I kind of said that, okay, 12 equals 10 plus 2. And then we're trying to multiply that 12 times 5. So rather than just jumping straight to 60, I broke the 12 up into the tens place and the ones place. Do you know what the tens place and the ones place are? Do you know what I mean by that? You're muted right now. I can't hear you. You're still muted. Oh, go ahead. No, you don't know?
I don't know. I don't know.
You don't know? Okay. When you have a 2-digit number like this, the ones place is the one on the right, and the tens place is the one on the left. So if I do 43, this 3 is the ones place, and the 4 is the tens, because it's 40, so 4 tens, and then 3. Does that make sense? That makes sense? Yes? Okay, good. So what I did here is I broke apart the 12 into 10 plus 2, and then multiplied each one by 5. So 2 times 5 is 10, plus 5 times 10 is 50. And altogether, that is 60. And this is just a different way to write that. You're still muted right now.
Let's mute myself. Okay. So the other one I need help with, 2 times 12 times 12 times 12.
12 times 12? Okay. This is one where this method will come in handy even more, I think. And it'll be an interesting way to do it, because both of these have numbers in the tens and the ones place. 12 times 12. Hi, Modi, welcome.
And then do we do 1 times 2? And the equation that we get from 1 times 2, do we add it to 2 times 1?
Well, go ahead and write that out the way you think it should be. So you've got 2 times 2 is 4. That's right. And then
1 times 2 is 2. And then
right. Now we need to multiply this 1. But
1 times 1 is 1 times 1 is 1.
well, we have to do the 1 times 2 also.
1 times 2 is 2. The answer is going to be 124.
Not quite. So I'm going to write this over here. 12 times 12. Because
Can I do a fraction after this?
what? When we go over to the tens digit, we have to basically write the next thing we're multiplying 1 row down. So 12 times 12, we start here, do the 1s times the 1, which is 2 times 2, and that's 4. And then we do 2 times 1, and that's 2. So we have 24. But now we're jumping over here to this 1's place, or the 10's place, the 1 that's in the 10's place. So we have to, when we go to the left on this, we have to add a 0 here and write the next answer here. So 1 times 2 is 2, and 1 times 1 is 1.
No. That's
And we add these two numbers together. And that gets us 144. I can't read what that says. It says can't do, what does that say?
Can't do fractions.
Can you say it over the, can you unmute yourself and say it?
could I do fraction?
Oh, okay. Well, we can just keep doing multiplication for now. Let's see.
James, I think he wants to do fractions.
Okay. Can you erase these markings? I'm not sure how to erase it from my end. Oh, I think I see. Okay, got it. All right, I see what you're writing out there. Okay, so 5 times 5. What is 5 times 5? 25. Good. Six times 5 is 30. 7 times 5 is 35. Okay. And do you know one of the tricks about multiplying by 5?
Yeah.
What's
It's
the
like
trick?
5 times 5. 1 is 5 times 1 is 5. 5 times 2 is 10. 5, 10, 15, 28, 25, 30, 35, 40, 45, 50.
Okay, right. So you know all the multiples of 5. That's great. And one thing you can notice there is that
No, that's
all the
7.
multiples of 5 end in either 5 or 0. And anytime you're multiplying by an odd number, like 9 times 5, the answer is going to end in 5. So that's 45. And anytime you multiply by an even number, like 8 times 5, that'll end in a 0. So 40, 8 times 5 is 40. Do you want to try a hard one? Okay, let's do a hard one.
Yes.
13 times 5.
It's going to be 65.
That's right, 65. And again,
14 times 5 is 40. I mean, 70.
okay, well, let's do an even harder one then. What about 123 times 5? Can you do that one?
First, I have to draw 5 times 5.
Okay, good start.
Let's do times 5.
3 times 5.
It's 15. I just remembered that.
Right.
And then 2 times 5 is 10. 10 plus 1 is 11.
She's
Then
good.
And
Good.
1 times 5. 1 times 5 is 5. Oh. Yeah, 1 times 5 is 5. 5 times. That's going to be 615.
Okay. Yeah, let's go through it. 123 times 5. So you did 3 times 5 is 15. You did
2 times 5.
2 times 5 is 10. And you did 5 times 1 is 5, plus 1 is 6. 615, that's right. Good work. So I think you've got multiplication by 5 down pretty well.
I know how to do all of them from 11. I mean 0 to 11.
Okay, so you can multiply by anything from 0 to 11,
Yes.
but 12 is what you're having trouble with?
Well, not with the 12 ones. Not with 12 times 1, 12 times 2, 12 times 3, 12 times 4, and 12 times 5. And 12 times 6. And then the rest, 12 times 7, 8, 9, 10, those are the ones I have trouble with.
Okay, 12 times 7 and 5.
A paper that says, yeah.
Okay, well, let's try one of those. Let's do 12 times 9.
9.
What would you start with?
I see. 9. Wait. I need a draw.
Okay, you can draw over here.
Okay. So, one. Then 12. Oh, I'm drawing with my mouse. Okay. 9 is here, and then that's going to be times. 2 times 9 is 18. 18. And then 1 times 9 is 9. 9 plus 1 is 10. That's going to be 108.
108. That's right. Good job.
Real quick.
Let's try 12 times 11.
Yeah. I have to erase this.
Hello. Who is writing on the screen? Esther, is that you?
12 times 11. Yeah.
James, I would say let's leave out double digit for now because they're mostly double digit is for fourth graders and everybody that's here right now are third graders. So
Okay.
you want to just stick to single digit or 2 digit multiplied by 1 digit, just like what you're doing. I'll say do more single digits drills. And Modi, are you there? I see Modi. Modi joined. Modi, do you have any homework you need help with?
I do have a fraction book.
Right.
Right.
I see your fraction book. So, but do you have any? What are you doing? What topic are you covering in school right now? Still measurements?
No, it's something new.
Okay, what is that?
I don't know, but it's about math.
Correct. So, can you please? Is there a way you can show us what it looks like so that James can help you?
Let me see.
Okay.
Oh, I think I know something. So, I was doing something in school, and I do not know what I do know what it is. So, when I was doing my work, I realized it was about perimeter. So, it's about how much. So, let's say you have a rectangle.
Okay.
And you want to see how much it costs on each side. Like we add up all the sides.
Okay, perimeter. Okay.
So when we're done putting all the numbers in it, but you can do squares. You can add squares to it, like a squares board. So whenever you're trying to write, it can show you then how much it costs, and then you write your number, and then you add up all the sides when you're done. So
Okay.
That's what.
So finding the perimeter of a rectangle.
It can be more than just a. It can be more than just a rectangle. Like a rectangle, like it can be It can be a square. It can be a star. It could be a star or a square or a square or triangle, anything except a circle.
Okay.
Oval.
Yeah, that makes sense. Okay, well, let's try a perimeter problem then. So here's a rectangle, and one of the sides is 7 and one is 4. So what would be the perimeter of this entire rectangle? Do you think you can do that, Modi?
It's gonna be 11.
Modi, are you there? Unmute yourself and James just asked you if you're able to do this question. Or if you want James to solve.
Yeah, I'm here.
Okay.
So.
Okay, so so this rectangle has 2 sides that are 4 and 2 sides that are 7. So what would the perimeter be?
What did they learn?
Well, I'll walk through it. It's got 2 7s and 2 4s. So there are 2 ways we can do this. We can either we can add up the 4 plus 7 and then multiply by 2, or we can just add everything together. So let's
It's gonna be 22.
4 plus 4 plus 7.
I cannot see you presenting.
What?
I cannot see you presenting. Oh, found it. I think I
okay.
found it. Yeah, now I can see you.
You see it now? Okay,
Yeah.
good. So 4 plus 4 is 8.
8. 7 plus 7, 14.
Plus another 7 plus 7 is 14. That's right. And what's 14
And,
plus 8?
well, you put the 2 in the bottom, put the 1 on top. So it will be. So you'll put the 1 on top, so it will be 22.
That's right. So the perimeter of this rectangle is 22.
And do you know another way you could do it?
What's another way?
So, do you have a kind of paper that has squares on it?
Oh, I know what you're talking about. I don't think I have that paper, but let me see if I can sort of make something.
Yeah, because whenever you can do those so whenever you try and do that, so when you look and you're like, oh, I do not understand how to do this, and you do and you add all the numbers and you see those squares, you count them and then you put them on the top and on the bottom and on the side and on the bottom. That's an easier way that you can do that as well.
Okay. So using graph paper, basically, with a bunch of squares. Let's try, okay, I'm going to grab something that, let's see.
That's how you could do it.
Okay. Here are some more problems. Oh. So let's try one of these. Let's do. Let's do number 1 over here. This shape, can you guys see that? It looks kind of like this. And this one's 9, 9, 15, and 11. So how would you do this one? Modi, are you still there? Modi? I'll go through it. So for this one, we have to add up all the sides, but it's not showing us the length of all the sides. So some of these we're going to have to figure out. We've got 11 over here. We've got 15. Another 9. And now we have 2 sides up here where we don't know the length yet. Esther, mute yourself when you're not talking to us?
I'll give you my marker. No, shame. No, I need nothing. My people will small books.
All right, well, I'll keep going through this. So this side up here, the way to find it is it's going to be 11 minus 9.
Yeah.
That equals 2.
Like this.
And this side is going to be 15 minus 9. And now we have to add all of these together. So 9, 1 is 10, 9, 24, plus 6 is 32. And 3 plus 1 is 5. Okay. You see these shapes here? Do you think you're going to find the perimeter of this shape? Esther? Do you know how to find the perimeters of shapes?
No.
Okay, well, let's go through this one here.
Okay.
We're going to count the number of squares for each side. So this side is 1 square.
There's 4. I mean, there's 8.
So, I'm having trouble drawing on it.
Sorry, I left.
That's okay. Good to have you
It
back.
kicked me out.
Huh. That's not good. Okay. Going through
In
more
Nigeria,
perimeter.
it's about 11.
When you were talking about the grid of squares, is this what you were talking about, Modi?
Yes. Yes.
Yeah.
Okay. So, Modi, can you walk us through this first one?
Yep.
Okay. How would you do this?
So you see all those squares?
Mm-hmm.
Those squares are something like a helpful thing. So you see on the top, and you say, "Oh, how can I do this?" And you look at that square, and it's only 1. So there's only 1 square on top of that.
Uh-huh.
We look on the side. We see we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 on the side. And because we already answered all of those two, we could just put, we already know, we already have 1. We already have 8. So we put 1 on the bottom again.
1 on the bottom again. Okay.
And 8 on the side again.
And 8 on the side again. Okay.
And when you're done with that, we add up all the sides.
Okay.
So 8 plus 8, 16. Plus 2, 18. What's...
I don't get this.
Okay, so we add up all the sides. So do you see all these squares in the box, Ether?
I don't get it because I don't get it.
It's like, so you have all of these, like 8, 8. We add up all the sides when we're done. So we know, do you see that top row? It only has 1 on top of it. On the side, it has 8 on the other side, 1 on the bottom, and 8 on the other side. 8 plus 8, 16, plus 2, give us 18.
That's right. So you're still having trouble figuring it out. What we're basically doing is we're looking at these shapes and we're saying, how long is it to go all the way around the shape?
Yeah, last time I had a test that I didn't understand. So it told me, so, and I have another way that I can do this that the teacher told me. So let's just say you have this and you have all these numbers, just pretend this is 16, this is 4, this is 8, and this is question mark.
Uh-huh.
And that's what I really need help with, because my teacher told me that after we're done, so when we do it, we have 2 sides, and then we add, like, do this. So that's what I do.
Okay, so ones where you don't know the length of one side is what you need help with?
Yeah, that's what I would do. On this one, yes, that's how I would do it. Because I don't know so much yet.
Okay, let me get one where we don't know all of it. Okay.
Oh, and if they have a test and they do not have any of those square thingies, you can make your own.
Okay, do you see these, Modi?
Yes.
Okay, this is what you're talking about, this kind of thing, right?
Mm-hmm.
Okay, well, let's look at number 2 here. All right, so number 2. So the first step in this is to find the lengths of these 2 unknown sides, right?
Well, yes.
Well, let's try to do that then. So this side right here, how do we find that length?
We find that length with that we add up all the sides first.
All the sides that we do know?
Wait, so is there a total?
It's not showing us a total right now. But we have 22 over here, 25, 6, and 18.
So I think how we could do this is that I would add 2 plus 5, 25 plus 22.
25 plus 22.
Mhm.
And then what would you do?
And I would add 6 and 18. So 5, 6, 7, 7, 4, 47. And then I do 47 plus 18.
Okay, 47 plus 18.
And it'll give me 15, 5, 1, 5, 6, 65. And
Okay.
now we add 6. 11. We have 71.
Okay. And now what?
Scale. So if we have 71, it says the shapes are not drawn to a scale.
Yeah. That means if you put squares in them, it would line up correct. But one thing that we miss, if we just add up these numbers, we're going to miss these two sides. This one right here and this one right here. So the first step in this problem is to find the length of the missing sides. So when we're looking at these sides, we want to line up, we want to based on the ones that are lined up the same way. So if we look at all the sides that are going straight up and down, we have the 22 and we have the 6, and then we have this one where we don't know how long it is. So to find that unknown side, what we need to do, we know that the 6 and this unknown one add up to be the same length as 22. So to find this one, we just do 22 minus 6, which would give us what?
Wait, 16.
That's right, 16. So that's what this side is, 16 millimeters. And now we look at all the sides that are going like this. So we have a 25, and we have an 18, and the 18 plus the blank side is going to equal 25. So 25 minus 18.
Oh, I see what you're doing.
Yeah. 25 minus 18. What does that equal?
25 minus 18. 25 minus 18. Oh, so we would take away the 1. 18, 17, 16, 15, 14, 13. 13?
Not quite.
20.
25 minus.
I'm trying to do it on the bottom because that helps a little bit. Okay, so we take away the 1. 15, 6, 14, 13, 12, 11, 10, 9, 8, 7, 6. Wait. 15, 14, 13, 12, 11, 10, 9, 8, 7. 7.
Right. That one is 7. So now we have all the sides, all 6 sides for this. And then we can start doing the addition 25. Whoops. Plus 22. Which equals 47. Plus 18. Which equals 65. Plus 16. Seven. 88. Is 94.
Oh, I need to start onto something.
94 is the total.
Can you go? Which one is Auntie Lilike?
So Modi, you see how to do that?
If I go.
Okay.
You can sign out.
Auntie Lillian.
Auntie Lillian.
I think she might not be on the call right now. All right. Is there anything else you want to go over really quickly, Modi or Esther?
Huh?
We've got
Okay, Modi.
Fraction.
fractions.
Yeah, me too.
Okay, I can talk about fractions a little bit. We're almost done with the hour though, but let's look at some fractions. Let's see. Let's go back to this page. And let's just look at, well, let's look at some of these. So a fraction
Or basement. Or
A fraction has two parts, the numerator and the denominator. The numerator is the top part. And
oh,
the
this is easy.
Okay, do
Oh
it.
yeah, this is 6/9, and the other one is
Okay,
gonna
then
be
what's 2
9/12,
slash 3
and then
equals?
the other one's 4/18, and then the other one.
Okay.
I wish I was learning this in school, but no, we're learning negatives, positives,
Okay.
integers, rational.
So here's an example of
How you
pie charts. 3/4 means that the pie is divided up into 4 pieces.
no, I'm gonna see myself.
And you have 3 of them.
How you like that?
Can you?
Oh, 7.
Okay, Esther, you're talking and you're distracting the class.
Okay, Auntie.
You need to pay attention when the class is going on. Yes, what do you need help with?
I need help with my whole. Can I chat? Can I send you a chat?
Send a chart to everyone so that James or Trisha can get it. They can help you. Okay.
Yo.
This is what a fraction represents, basically. A piece of a pie is a good way to think about it. Or a piece of pizza, even. So 1/6, if you divide it up into 6 pieces, one of those 6 is 1/6. All right. We've got a question. Is that right? On homework? Yes, no? Any more questions?
I have a question.
Okay, go ahead.
So, the on the pizza slice, you see the shaded green thing?
Yes.
So the colored green thing goes first. So you see on A,
Yes.
the big number is down, which is the same thing as denominator.
Yeah,
And so the shaded number goes on top.
that's right. Yeah. So if you have, if you divide a pizza up into 4 slices and you have 3 of them, then you have 3/4 of the pizza. That's
Let's
a,
just stop.
and that's what,
I have a question.
go ahead.
So I'm doing hold on.
I'm doing negative and positive.
I need help with my homework from school.
Okay.
So, well, I'm doing in school, so I can't really like share my screen. But actually, I think I can. Let me just. I'm gonna share my screen. What's the thing?
Institution.
No, it's my homework. You don't know what it is. Sure. Can you go?
No! That's not your username. That's Elizabeth. You see.
Okay.
It's over there.
Esther, go eat your apple somewhere else. There's no noise.
This is bully mom.
Yeah, I know.
And I think that's my
No.
question.
Can you please move?
What's the question, Modi?
Yeah, that's all.
Oh, okay.
Okay, now I'm
That's all
going
the
to
things I wanted.
How?
copy this.
So you can still do work online.
Well, the teacher just puts it online for the online. Well, I don't think she even teaches. Okay, can you like stop sharing your screen so I can share, please?
Okay.
Thank you. Thank you. I'm gonna share that. Okay. So this is this week, right?
And this one's, what grade are you in? Because this is a little,
Sixth.
okay, so this is a little beyond 3rd and 4th grade. I think we've passed the hour for 3rd and 4th grade anyway, so that's all right.
Oh,
But we can go through this really quick too.
okay.
Yes. Oh, okay.
I just need help to check a question if I got it correct.
Okay.
So for this one, like this question,
Number 2. Okay.
yeah, I got is 4 and Hold on, I need to wait. No, that's not right. That's not what I put. I'm coming. Let me go get my answer. I got this is what I got as my answer. So is that correct?
That's close. Is that
Simplified. This is the simplified.
positive 5.5?
I think, I don't know, would it be negative?
It would be negative because you have negative 4 3/4, and you're going
And
down 3/4 more than that,
okay. So,
even further negative.
okay, thank you.
You're welcome. All right. Okay, I think that's all the time we have today.
Okay. That's thank you so much, James.
Auntie, Auntie,
You're
Yes,
welcome.
sister.
I have a quiz tomorrow on math, and I still need I need help to remember everything because I just started fractions again and I really haven't done negatives and positives yet. So I need help, more help.